Hello and welcome everyone to today's webinar sponsored by Hudson Technologies. My name is Katie Gillum. I am the event director for Green Build, and I'll be your host for today's session titled The Refrigerant Landscape and the Role Reclaimed Refrigerants Play in Green Buildings. First, just a couple of quick housekeeping items if you didn't see those slides previously. If at any time you experience technical difficulties with audio or the slides are frozen, refresh that screen with F5. F5 usually takes care of like 90% of the issues. But if there's more issue than that, there's a question mark button and one of our team members will assist you there. At any time during the presentation, you can submit your questions in the Q&A window on the left-hand side of your screen. I'll come back at the end and read off those questions for our presenter today. And then in 24 hours, you'll receive a link to watch the recording of this session. So now I would like to introduce our speaker today. So we have Kate Houghton, the Senior Vice President of Sales and Marketing for Hudson. She has over 25 years of marketing experience within industrial manufacturing companies, and just found out she also went to Boston University like I did. So go Terriers, and I will give Kate the floor. So Kate, it is all yours.
Thank you very much, Katie. So it's the Kate and Katie show today. And so thank you very much, everyone, for joining us. Just less than 30 seconds are about me. As Katie said, I'm the Senior Vice President of Sales and Marketing here at Hudson. I'm a mechanical engineer by trade. I also did a degree in commerce and marketing. I did both those back in Australia. And then I did my MBA at BU, Go Terriers, and we're going to win the Beanpot this year. I've been in the HVAC industry for 10 years. Prior to that, I spent 16 years in the special hazards fire protection industry. So there's a lot of similarities between those two, and there's a lot of differences. And I was very fortunate last year to be awarded the ACHR, one of the ACHR top women in HVAC last year. So it was very exciting. I'm going to dive right in. So our agenda today, we're going to talk a little bit about Hudson, just so you know who we are and why we're talking about reclaimed refrigerants. We're going to talk about refrigerant regulation, what that means to the industry. A really important topic, lifecycle refrigerant management, and how that relates to carbon reduction and why we're all here today. We're going to talk a little bit about our on-site services, refrigerant reclamation, and we have plenty of time for questions, so please do not be shy. So here at Hudson, we're very much focused on sustainability, and it impacts and drives everything that we do. So our mission here is improving environmental quality and promoting a healthier planet through the sustainable recovery and reuse of natural resources. So everything that we do is really around that. We've been supporting the circular economy for refrigerants since we were founded. We've been in business for over 30 years. So everything from that initial sale through its use to reclamation, operating systems, and thinking about all of that in a sustainable manner is what we do here at Hudson every day, all day. So I mentioned we've been in business for over 30 years. We were established in 1990. We're really experts in chemical engineering and technical expertise around refrigerants and HVAC systems. So on the refrigerant side of your systems, how they work, how to optimize them, what the carbon footprint looks like, that's what we do. We're one of the largest companies in our industry for both refrigerant reclamation, so we're one of the largest reclaimers here in the US, as well as being one of the largest single independent distributors of refrigerant in the country. We are AHRI certified in our laboratories. We'll talk a little bit about that. And we're really seen as an industry leader as it relates to regulation and participation in regulation and driving the industry from that perspective. We do many things in our business. We sell refrigerant, obviously, and we're going to talk about that a little bit today. We buy back refrigerant. So many people are surprised to hear that used refrigerant has a value, and we'll certainly cover that as we go through. We are an AHRI certified, an EPA certified reclaimer, and it's a large part of our business and that circular economy of our business. We have an on-site service team that is in the field remediating systems and doing recovery. So those two things happen with our service team. And again, everything is about managing refrigerant as an asset, managing your systems with sustainability in mind. Just some quick statistics. In 2021, we achieved carbon neutrality of our California operations. We have a number of facilities around the country. In 2022, we achieved carbon neutrality across all of our reclamation facilities. So it was an important milestone for us. And you can see over the course of years, the emissions that have been prevented by our reclaimed refrigerant. So when we reclaimed, we recovered that refrigerant, we've prevented its release to atmosphere. We've taken more than 18 million cars off the road, or the equivalent of taking more than 18 million cars off the road. We've charged numerous cell phones. I've probably been responsible for many of those. Again, over 16 million homes that we've been able to electricity for 1 year and prevented that. So a significant measurable contribution that we've been able to be providing to the industry. We are national in our presence, so we have over 40 locations from refrigerant, from our service depots, from our reclamation facilities. We are publicly listed, and you can follow us. HDSN is our ticker. We have over 7,000 customers in our active customer base, and so we work everywhere from wholesalers through contractors to end users. So we understand, again, refrigerants and HVAC systems from all of those perspectives. We have 3 reclamation facilities, one in California, one in Illinois, and one in Georgia. And we're one of the very few companies whose laboratories are AHRI certified, and then we're very proud of that. So a very quick introduction, because I really want to get to the heart of what we're here to talk about today in refrigerant regulations. But before we do that, we're going to start off with a poll.
Yep. So this is so we're going to have 2 polls. So your chance to let Kate know your feedback here. So the first question is, my facility currently utilizes refrigerants. Choose all that apply. So A is CFCs, B is HCFCs, C is HFCs, D is HFOs, and E, neutral refrigerants. So I will give you guys a moment to submit your usages there.
A little bit of a tongue twister there, Katie.
I know. I was like, you're really putting me through my paces today. I chose to not read the parentheses there.
Well, my Australian accent with my questions is always interesting as well.
Yeah. Just give it an extra couple seconds here to get your pieces locked in. All right, I'm going to move it to the next slide. All right. So it looks like HCFCs, by and far winner.
All right, so that's really interesting that HFCs and 410 and 134 and 408 are the largest, because that's really what we're here to talk about today. And the current regulation in refrigerants that we're talking about is relevant to HFCs. Probably no coincidence that that's the case. But what's interesting before we move on is with 8.8% of the audience that answered the question still is utilizing CFCs. And when we move to this next slide, we'll see why that's really interesting. So CFCs were fabulous refrigerants, R11, R12, and R11 was very prominently used in chillers for buildings. CFCs are ozone depleting substances, and they also had very high global warming. Those refrigerants were phased out of production and importation in 1994. So the fact that 8.8% of our audience still has CFCs in their building talks about the longevity of those refrigerants, talks about the life cycle refrigerant management that's happening with those refrigerants, and really shows us a path as we move forward with HFCs. So CFCs were phased out because of the ozone depletion potential. The industry moved to HCFCs, and so those were really R22 is the most common, and 123. So if you had a chiller in your building, likely 123 was one of the refrigerants that you moved to. It could have been R22 as well, depending on the application. HCFC still had a small amount of ozone depletion potential and a lower global warming, but still a significant global warming. In December of 2019, import and virgin production of R22 in particular ceased. And so from that point on, the refrigerant was only available, those refrigerants are only available through reclamation. There's a small tail of virgin production of 123 still left, but that's tailing off quite quickly, and virgin 123 will be phased out here very shortly as well. What happened in that phase out, though, is that the equipment that particularly in R22, was addressed first. So equipment ceased to be available while the refrigerant was still being produced. So the refrigerant to service the installed base was still being manufactured, could still be imported, while the equipment was phased out. And that's going to become really important right now, because when we look at the HFC phase out, so your 400 series refrigerants, 404, 410, 134A, the AIM Act was passed very quickly, and it was passed in December of 2020, and it became 1 year in order to address importation of refrigerant, but the equipment is still being produced today. So we've started to phase down the HFC availability, while today and even next year, you'll still be able to install HFC equipment. So it's a very different phase down than previous, because we're growing the installed base. We continue to need these HFCs while we're reducing their availability. So HFCs have zero ozone depletion potential. They certainly have a lower global warming potential than CFCs, but still a global warming impact. And what we're moving to as an industry is HFOs. So zero ozone depletion potential, and on average, much lower global warming potentials. So I mentioned the AIM Act. The AIM Act, again, was passed in December of 2020, and it has a number, we could talk about just the AIM Act itself all day long. It has a number of areas that are really important for us as we think about reclaimed refrigerant and green buildings. The intent of the AIM Act is to force a virgin HFC production phase down. So, and phase down over a series of years to out into the late 2030s. It's very deliberate by putting in an allocation system for both production and consumption. The availability of HFCs will be reduced. It also requires that we maximize, and the EPA is required to promulgate regulations to maximize recovery and reuse and reclamation of those HFC refrigerants. So there's standards that are being put in place, and the EPA is required to promote those and is actually required to help grow reclamation and recovery of refrigerants. It's also moving us towards HFO technology, so lower GWP technology. And it's doing that through a couple of different ways. We'll look at a couple of different mechanisms, largely through the Technology Transition Rule, which was finalized last October and was published last October, and we'll take a little look at that. At the same time, the public comment rule for the refrigerant management, so you might hear it called subsection H. It's the EPA requirements for those regulations to grow reclamation. So that rule was published for comment in October. The comment period closed in December of last year, and we'll hear about that, what the final rule is, sometime in early Q3 this year. So again, there's lots of other elements about the AIM Act, but as we think about refrigerants in green buildings, these are the ones that we're going to talk about specifically today. Many of you may have seen this chart. There's been a lot of conversation about the AIM Act over the last 2 or 3 years. Again, the AIM Act is basically focused on phasing down virgin HFCs. It does not require a restriction on the use of recovered refrigerant, reclaimed refrigerant. In fact, it promotes the use of reclaimed refrigerant. So as it's mentioned, the Act was passed in December of 20. There was 1 year while various elements of the Act were regulated, and then it commenced in 2022, and there was a 10% reduction against the baseline that was established of all of the HFCs that were imported in use here in the US. In January 1 of this year, that step down moved to 40% against the baseline. So there was a 30% reduction over last year's availability. And what you see here in the gray area is that gap between what's available and what's expected to be needed in the marketplace, because we continue to install HFC equipment, and we're going to continue to need to service that equipment for 15 or 20 years to come, possibly longer. So we're starting to see that impact now of that 40%, and that 40% will remain out through 2029. And we'll see, again, no more additional availability. It's going to be flatlined, and so this 40% reduction will remain in place. So I mentioned it's a different kind of regulation in this regard. In past experiences, we regulated particular refrigerants. So for example, the HCFC was regulating R22 specifically. In the AIM Act, we're regulating a bucket of refrigerants. So everything that's HFC that's named, and there's multiple HFCs across multiple industry applications, so not just HVAC, but fire protection and foam blowing and aerosol applications. All of the HFCs used are encompassed in the AIM Act. And what the AIM Act does is take those refrigerants, takes the GWP, and then converts that to an allocation system so that each refrigerant is treated equally. What do we mean by that? Every refrigerant requires an allowance proportional to its global warming potential. So you see here on the chart on the right, these are the most common HFCs that are used here in our applications today in buildings. The higher the GWP, the more allowances are required to either make that refrigerant here in the US or to import it. So 134A has one of the lowest GWPs compared to 507, and we'll see some comparisons in a moment. But that's how it works, is bundling all of those HFCs and treating them equally on the basis of GWP. Anyone who holds an allocation can choose what they want to do with that allocation. So they may decide to make 507, or they may decide to make 134A, and that's really up to the allocation holders. Because the high GWP refrigerants require more allocations, some applications will see tightening of supply and tightening of availability faster than others. So again, here you'll see 404A requires a lot of allocations to make a pound. And we're already in industry starting to see indications that 404A, some producers and some manufacturers will actually cease production of 404A this year. So if you have that in your applications, the virgin production or importation is starting already to be indicated that a number of folks are exiting that business this year in favor of other HFCs. So what becomes really critical is reclaiming the HFCs that are in use, and so making sure that we capture those, we recover those, we reclaim those so that we can support that install base. And we can give the transition time between now and when that equipment times out in terms of end of useful life, and that we don't have to change equipment any earlier than necessary. Equally, HFOs have required changes to the building code. And so the building code needs to adopt, and building codes around the country at both a federal, state, and local level need to allow the use of mildly flammable refrigerants. That's increased over the last year or so, but we're still probably a year away from building codes across the country being normalized, if you will, to allow flammable refrigerants and the use of flammable refrigerants in A2Ls and HFOs around the country. So that building code is really what's meant that we had to keep installing HFC equipment. This just gives you a very visual. If you have 410A in your system today, on the left-hand side, you'll see a representation of how many allocations that you would need to produce a pound of 410A today. And what that converts to if you replace your system with R32 or R454B. So R32 and 454B are the most common replacements for 410A. Now, I'd be remiss if I didn't say you cannot convert a 410A system to use either 32 or 454B because both of those refrigerants are flammable, and 410A equipment is not designed to utilize flammable refrigerants. So you can't convert a 410A system, but if you're replacing it with new equipment, you're likely going to choose either 32 or 454B. For 1 pound of 410A, under the allocations required to make 1 pound of 410A, you could make 3.1 pounds of 32 or 4.5 pounds of 454B. So again, you'll see the allocation system is driving that adoption to lower GWP refrigerants. And producers will decide whether to make 410A or to make 4.5 pounds of 454B as we move forward. You can kind of see where that is going with the applications. Again, a very similar kind of math. 134A is a very common refrigerant used in chillers in buildings. The most common replacement for 134A is 513A, which has a much lower GWP than 134A. So for every 1 pound of the allocations needed for 1 pound of 134A, you can produce 2.5 pounds of 513A. Again, so you can kind of see how that math works and why this AIM Act is driving us towards those lower GWP refrigerants. So refrigerants can be a little bit of an alphabet soup. And we kind of laugh here about the letters and the numbers and what have you. But this gives you there's a lot more refrigerants available than this, but this gives you a high level kind of understanding of the current most common HFCs, so 134A, again, refrigeration and chiller applications. It's very common in buildings, in chillers in buildings, and also used in refrigeration. 407A, 407C, 448, 449. Those last two are largely used in commercial refrigeration, though again, you would see them often in buildings in the commercial refrigeration applications in a building. The next bucket of GWP below 700 is important because that's where regulation is driving for the technology transition rule that we're going to look at in a moment. So as we move forward, a limit on GWP in various applications, the refrigerants used will need to be a GWP of 700 or less. So as I mentioned just on the previous slides, R32 and R454B, they're commonly used in air conditioning, or you might hear it called comfort cooling applications. And they're the replacement agents for 410. But as we talked about earlier, the most common, as we talked about earlier, you cannot retrofit 410A systems. You have to put new equipment in to use either R32 or 54B. 466A is a refrigerant that is not yet SNAP listed, but we expect SNAP listing later on this year. It's going through the approval for EPA. 513, again, generally used in chiller applications to replace 134A, so comfort cooling, industrial refrigeration chillers, all of those applications. It is currently commercially available. Again, you'll see 573 GWP versus 1430 GWP of 134A, hence close to 3 times per pound. Then the next bracket is, in looking out further in state-based regulations, some states are starting to look at what if the GWP limit in refrigerant equipment and HVAC equipment was 150 or less. So these refrigerants meet that criteria as well. And as we look further out and in different state levels, this is something that we're keeping an eye on for regulation over the next few years. So 514A, which typically is replacing 123, again, it's already commercially available, has a GWP of 2. Generally replacing 123 and used in chiller applications, and obviously meets that 150 GWP limit. Again, you can see here YF, generally used in mobile AC, though we sometimes see it in buildings. 1233ZD, again in low pressure chillers, also a replacement for 123. And 1234ZE, it's an A2L, again, generally in refrigeration and chillers, also commercially available. And all of these are below the 150 GWP limit that we might see in the future. So I've talked a little bit about HFOs and what does HFOs and A2Ls and mildly flammable, so many of you may have heard of mildly flammable and H2O. So the flammability scale is balancing toxicity and flame propagation, and so it's measured by those two factors. The refrigerants that we've been commonly using up to now, as we think about the R11, if we take a typical building that might have had a chiller system, R11, R123, 134A, ZD, things like that, those are A1 refrigerants, no flame propagation, so there's no flammability and very low toxicity. So as you see that on the EPA, they're approved for all kinds of applications, and so they come through the SNAP rule like that. As we've moved forward, and we're moving to lower GWP, in order to get some of these refrigerants to replace those applications, flammability has been part of that path. Now, mildly flammable means that in an A2L, so you'll hear these called A2L, so 454B and R32 are both A2L refrigerants, mildly flammable. You'll see here on the chart here. And so what that means is generally it takes a lot of energy. It takes a lot of activity to, in fact, ignite those refrigerants. And if you can, they burn very slowly and they do not burn very intensely. So it's not like, often we'll get asked the question, is it like having propane in my building? And so propane and hydrocarbons are starting to get used in very, very small applications like cases and small domestic fridges. Those are very flammable. Mildly flammable really means you have to work very hard to ignite them. It's far more difficult than your propane. It's nothing like propane. It's very, very difficult. The burn rate and the flame propagation is very, 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 very small. Right? So let's look at the technology transition rule and what is the timing here of how refrigerants and equipment will start to transition. So starting as early as next year, so you look at that January 1, 2025 date and think, well, that's a ways away, but it's already February of 2024, so who would guess? But starting January 1 of 2025, stationary air conditioning, residential heat pumps, those kinds of applications will require that the equipment uses a refrigerant with a GWP of less than 700. So we looked at that chart a moment ago. And you will not be able to manufacture or produce equipment that currently uses 410A, as an example, because that has a GWP over 700. Now, there was a lot of conversation about this because the rule was published in October of last year, and there was a lot of conversation about sell-through rates and what if we build it but before December, and the industry talked about, but then we can't use it. So the EPA issued a good cause rule in late December saying if the equipment is manufactured and built and assembled, essentially, by December 31st, then there is a 1-year sell-through. So if a contractor, if a wholesaler, if an end user has a chiller, has a piece of equipment, and it's not yet been commissioned and fully installed, you have 1 year sell-through and 1 year time frame to get that into service. After January 1 of 2026, you will not be able to install, commission, purchase a new system in this category that uses a GWP of over 700. So there's, again, little flexibility here that's been given just to recognize that supply chain takes sometimes a little bit to catch up. And we don't want to strand equipment that's been produced and then can't be used. So again, you see technology transition based on various elements. So various chillers and applications and process refrigerants, depending on certain criteria, also then have a very similar requirement, GWP of less than 700. So you see here in industrial process refrigeration where the fluid is exiting above minus 30 degrees. After January 1 of 2026, you will not be able to use a piece of equipment that uses a GWP refrigerant of greater than 700. So it's really important. We've probably got a lot of range of industries and applications here today because buildings cover a lot of ground, everything from data centers to business offices and manufacturing facilities and things like that. It's very important to be looking at your application, your equipment, and a chart like this to understand what you need to do to plan for the future as you're thinking about upgrades and new equipment. So one of the last things I want to talk about in terms of regulation, before we talk a little bit about lifecycle refrigerant management, is that we've spent a little bit of time talking about federal regulation and the AIM Act. But it's really important to know that in today's day and age, regulation is far more than just federal when it comes to refrigerants and applications, that the states and many states are looking at refrigerants and equipment over and above the federal requirements. So this just gives you a sense of the number of states that are looking at regulation that is more stringent than the AIM Act and that is moving faster than the AIM Act and where they're at in that process. So again, we could talk all day today just about this topic. So I think the takeaway here is it's important to understand that the AIM Act and federal regulation may not be the final say as it relates to your use of refrigerant and your use of equipment. And really looking at your local state regulations is very important. So let's use California as one example here. So again, we could talk about each state individually, but in California came out with a regulation several years in front of the AIM Act. Actually, it was being worked on for several years. The purpose of California was exactly like the AIM Act, that California was looking to move from higher GWP refrigerants to lower GWP refrigerants and wanted to accelerate the adoption, particularly of things like R32 and R454B. But they ran into the roadblock that building codes in California, again, did not allow the installation and the application of mildly flammable refrigerants. So CARB, the California industry body, or the California regulatory body, and industry, folks like Hudson, we participated, equipment manufacturers participated. And the regulation order that came out was that CARB requires OEMs, so makers of original equipment, whether that's HVAC, whether that's commercial refrigeration, across all of the refrigerant applications in California, things like, again, ice rinks and chillers and things like that, that during this time period up until next year, that 10% of the factory charge of that OEM equipment needs to be reclaimed refrigerant. Recognizing that in this instance, recognizing that reclaimed refrigerant has a significantly lower GWP than virgin refrigerant, and so trying to get that lower GWP usage in California by incorporating the use of reclaimed refrigerant. And so this was really a first for our industry, where OEMs are now using, and anybody who sells equipment into California, this applies, not just for the equipment that goes into California, but for their whole equipment. So that 10% is based on their equipment sold around the country. And this, again, would be a first where OEMs are now utilizing reclaimed refrigerant and recognizing that reclaimed refrigerant is equivalent to virgin refrigerant. We're going to talk a little bit about that as well. So then the second thing that California did a little bit over a year ago, so still getting used to saying 2024. So on September 30th of 2022, they passed SB 1206. And SB 1206 takes the regulation to the next level and says that the sale or distribution of bulk HFCs exceeding particular GWP limits is banned in California over a period of time. The catch here is that bulk refrigerants are not large quantities. Bulk refrigerant is essentially any refrigerant that's packaged. So some of you, again, building owners, property managers, facility managers, may go to, maybe buying your refrigerant in 24-pound cylinders. So have those small disposable cylinders for emergency use or applications. That's considered bulk. So as little as 24 pounds or as little as 9 pounds, and some of these smaller cylinders, that's included in this regulation. So as of January 1 of next year, again, January 1 of 2025, you will not be able to sell refrigerants with virgin refrigerants with a GWP of more than 2,200 into the state of California. A wholesaler can't buy it, a contractor can't buy it, an end user cannot buy it. So next year, 404A and 507 virgin refrigerants will not be available for sale in California. SB 1206 also requires the use of reclaimed refrigerant for certain sectors for servicing. So again, building that demand for reclaimed refrigerant. So this has a very wide-ranging impact and really starts to set the stage for thinking about refrigerant management, thinking about life cycle refrigerant management here as well. So where are we going? Again, we've talked a little bit here. HFC's products are starting to have demand, and reclaimed refrigerant is starting to have demand. Installed base is continuing to grow while we're phasing down the availability of that refrigerant. So bridging that gap, the need is not going away. Bridging that gap comes down to utilizing reclaimed refrigerant and planning and using that to allow the planning and the orderly transition of equipment and refrigerants to HFOs. That becomes really important. So here is Hudson. Again, I mentioned we're one of the largest reclaimers in the country. We're one of the largest distributors of refrigerant. We can help you bridging that gap with that reclaimed refrigerant. We're going to talk a bit about Emerald refrigerant as we move forward. We also have services to help with your recovery, your chiller conversions, and your HFOs. So really thinking about all of your system holistically is where we can help. So let's turn to talk about lifecycle refrigerant management and carbon reduction, and what that means as a building owner and in the environment today. So often we would talk to building owners, property managers, facility folks, contractors even, and people would tell us they view their refrigerant as a liability. It's, I've got to handle this. It's like these regulations, I've got to, and really look at refrigerant in something of, my slide somehow keeps jumping around. Somehow view that refrigerant as an asset, and that's what we're trying to move towards. How do we get folks to understand, and how do you start to think about your refrigerant as an asset versus your refrigerant? I'm battling my slide here somehow. So thinking about that is a really important part of refrigerant life cycle management. How do you manage your refrigerant by looking at it as an asset versus a liability? And then again, life cycle refrigerant management, carbon reduction. How do you lower your carbon footprint? By moving to a lower GWP refrigerant. So when you recover those refrigerants and you're doing a conversion, the recovered refrigerant can actually help funding for that process. We're going to talk about refrigerant reclamation a little bit today as well. And we have some very unique capabilities that we can maximize your recovery of the amount of refrigerant, and we can reduce your downtime. And we're going to talk about chiller decontamination and our services that we can do there as well to help make that process and to help your operating. If you're not ready to convert your chiller yet and you want to keep that running, we have methodologies for that as well. So life cycle refrigerant management, there's 6 pillars of life cycle refrigerant management. And there was an article, a paper published called the 90 billion ton opportunity. And that 90 billion ton opportunity is the avoidance of emission of greenhouse gases, HFC refrigerants largely. And if we prevent that and we manage that through these 6 pillars, then we're going to be able to avoid 90 billion tons of greenhouse gas emissions. So the first is really looking at product stewardship. How is it that we manage our footprint, and how do we make sure that we're always capturing every pound and recovering every pound? And how do we think about our refrigerant? The second is increasing the recovery and reclamation of the refrigerants. So making sure that old refrigerant gases do not get released to atmosphere, and that every pound is considered valuable and every pound goes back to a refrigerant reclaimer. You might wonder why reducing leaks is important. Reducing leaks in systems ensures A, we're not having fugitive emissions out into atmosphere. And then also means that when you're ready to convert your system, that the maximum amount of refrigerant is available for recovery, leading to the maximum amount of economic value from that refrigerant, and therefore helping to fund more of that conversion. The fourth pillar is really looking at reporting and enforcement. So from a perspective of, are we ensuring that all of that refrigerant is being managed correctly? So our contractors, our facilities, our EPA reclaimers, all of us have a role to play in reporting and enforcement as it relates to managing those HFCs and those fluorocarbons. I'm not sure how many of you in the audience have had trouble with technician availability and technician, just experience. And so it's a challenge in a lot of areas of society today, but HVAC technicians, refrigeration technicians, they're in scarce supply. So how through lifecycle refrigerant management can we train technicians, get a better workforce, and again, make sure they know how to recover, reclaim, reduce leaks, and again, keep hold of that and view the refrigerant as an asset, not a liability. And lastly, again, back to training, back to technicians, back to the workforce. How do we ensure that installing, servicing, that systems that are installed are put in correctly, that they're leak-free from the day that they're installed? So how do we make sure that's a 6th pillar here, that from the day the system is installed, we're thinking about refrigerant management from that timeline. So as I mentioned earlier, looking at lifecycle refrigerant management, and by the way, what I didn't say was Hudson was a co-author of that paper, and we were a contributor to that paper. And we were authors that with the EIA, the environmental agencies, NRDC, and Hudson, and a couple other folks. So, this is near and dear to our heart as it relates to sustainability. So by doing this, we can prevent 90 billion tons of metric CO2 equivalent being released to atmosphere. If you think about life cycle refrigerant management, it's really about the circular economy. And how do we make sure that we take what could be a waste product and turn it back into a valuable asset, right? And you think again about net zero and going to that path, circular economy is going to be really important so that nothing goes to waste. We often hear it talk at Hudson that where it starts, where all of this starts, where everything starts, is that first pound has to be recovered. So without proper recovery, refrigerant reclaimers like us can't do anything. We can't reclaim what isn't recovered. And if it's not recovered, it's likely being released inadvertently to atmosphere. So making sure that recovery, reclamation, that we all can be part of that circle is really important. And that's, again, lifecycle refrigerant management across the entire chain is really critical. Again, leak reduction, leak maintenance, if it doesn't leak, it's available for recovery. And if it's available for recovery, then it's available for reclamation. And so it's a really important factor here. Here at Hudson, we want, as a reclaimer, we want to pay for your recovered refrigerant. We want to give you the economic value for you managing that refrigerant successfully. So again, lifecycle refrigerant management, preventing leaks, maximizing recovery, that leads to economic value for you as a system owner. And finally, it allows us to orderly manage the transition. So through recovery, through reclamation, we can then keep systems that are still in service in use. And again, if I go back to where we started here, 8.8% of our audience is still using CFCs. The only way that happens is through lifecycle refrigerant management. It's that making sure that the refrigerant is recovered when that equipment is coming out of useful life, because there's other equipment that still needs that. Right? It's a key element. All of these factors are very important to making sure that we're not emitting greenhouse gases and that we're recovering them. So we're going to move to our next poll. I'm going to call on Katie again.
Yeah, sorry about these slides. I'm not quite sure what gremlin is in the computer at the moment, but it is definitely jumping. So hopefully taking this pause will work on this. So we do have a poll question here for you all, which is, my organization is evaluating ways to reduce carbon footprint of HVAC systems using the following. So I know the last question, we had some issues with selecting all that apply. So if that isn't working, select the one that you use most often.
I'm curious to see the answer to this one, Katie.
Yeah, you've had some great questions come in also, so.
I know, I'm looking forward to getting to them. We got a few more slides, but not too much. Trust me, folks, we're getting close to your questions.
All right, looks like we've got most of our attendees here. So I'm gonna advance this one. Hopefully it sticks. And then hopefully the ones moving forward do as well. Oh, like a pretty even split here, actually.
Wow, that's really interesting to see. So, you know, and often that balance between you want to replace aging equipment, but you're planning for that, but you have to keep your existing equipment operating as efficiently as possible. So it's not an uncommon kind of split. Converting existing equipment, so one in the middle, it's the smallest percentage here, 14.5%, but it's still something really interesting and really important in terms of carbon footprint. We're going to talk really about all three. So I'm going to keep going here. All right, so let's talk about our on-site services and refrigerant reclamation.
Hold on just a second. The slides are still jumping a little bit. Let me see if I push them, if that would work a little bit better. So Kate, if you just want to just cue me for next slide, then I'll try to do it on my end here. We'll see.
Okay. All right, great. On-site refrigerant services here at Hudson are really focused around optimizing the energy efficiency and reducing the carbon footprint of operating equipment. Generally, we're talking about large chillers, industrial process refrigeration, and applications like that. We're not really talking about residential like commercial. So we have some patented and proprietary equipment called the Zugabees. It's designed to be fast and portable, we can go through a standard doorway. So this is how the equipment is designed. It can go into any building. It can go through an elevator, through a doorway, and we can take it anywhere to where your equipment is and to where the problem is. We do this nationwide. Using that equipment, we can move over 6,000 pounds of refrigerant an hour. We can recover and we can clean and we can process on-site refrigerant in that basis. So very large capacity, again, patented and proprietary. It allows us to recover the maximum amount of refrigerant. So as we're doing a recovery for you, nothing's left in the system. We're pulling all of that out. Why is it, including pulling down vapor? Why is that important? Because you really want to make sure that we're recovering everything and everything is coming out of that system. From the release of refrigerant, you don't want that to happen. So that's where we're going to recover the maximum amount, as well as that economic value. We're making sure in doing all of our services, and I'll talk about those right now. So we have the ability to do moisture reduction. If you're a refrigerant, if you have a tube leak in your chiller and you get a little bit of water on your refrigerant side, we can reduce that moisture. If, for example, you have a catastrophic failure and you get a lot of water in your system and you've got standing water in your chiller, which is more common than you might think, we can do a full-blown system dehydration. Anything that becomes a contaminant in the refrigerant side impedes the heat transfer ability of that equipment. When you impede the heat transfer of the equipment, what happens is you increase the energy usage, you get a less optimal design output, so less cooling factor, like we just talked comfort cooling. You're going to get less comfort cooling, but you're going to use more energy to do it. So our remediation services and our refrigerant side services, and we call them on-site R-side services, are all designed to remove those contaminants, to remove the impediment to heat transfer, to make sure that we return that system to a lower energy and the design energy optimization. When you do that, you're lowering your carbon footprint. And over time, all of these systems drift. Again, you might get oil log chillers where there's a problem and somebody adds a little bit more oil, and more oil, excess oil in the system is going to impede heat transfer. I'm sure nobody in the audience has ever seen this, but sometimes what we'll see is the wrong refrigerant is put in a chiller and you get cross-contaminated refrigerant in the chiller. So 123 put into a 134A chiller, for example. Not that anybody on the audience has ever seen it, but again, I'm sure you have. So that cross-contamination of refrigerant, again, Hudson with our R-side services can decontaminate that refrigerant on-site. We can separate that refrigerant on-site at 6,000 pounds an hour. Again, when you're reducing the contaminants, when we're making sure that you're returning the refrigerant side of that system back to design, you're going to lower your energy footprint, you're going to lower your carbon footprint, you're going to optimize that chiller operation. And we're, again, nationwide and able to provide these services. What's also really important is recovery and system conversion. So that same equipment and that same methodology, we recover all of the refrigerant, we can recover the oil out of your system. And we can do that on-site very fast, 6,000 pounds an hour. We can get that system ready for a new refrigerant. So if you're going to do a conversion, if you're going to take your 123 chiller and move to 514, for example, we can help you do all of that. Recover the refrigerant, recover the oil, get the system ready, clean the shell, as well as paying you for that recovered refrigerant to help fund the conversion, and then inject the new refrigerant for you. So it's a service that's available nationwide. All of that activity, we can give you the details of the refrigerant that we've purchased, so you can use that for your ESG goals as well. Proactive maintenance, again, to see that drift and to understand where you're going with that system. We can we can track your oil and your refrigerant and do proactive maintenance. So if you want to know what's happening in the trending that's happening, is there a problem with your refrigerant over time? We have a service to do that too. So let's talk a little bit about Emerald Refrigerants. So Emerald is our brand of certified reclaimed refrigerants. It meets CARB R4 requirements. So California has a standard for reclaimed refrigerant. It's called R4. And our Emerald Refrigerants meets and exceeds that standard. Again, under Lifecycle Refrigerant Management, you may choose to use reclaimed refrigerant in your equipment, because reclaimed refrigerant is recognized to have a lower GWP than virgin refrigerant and an almost near zero GWP. So as you're looking for your ESG goals, as you lower your carbon footprint, emerald refrigerants and reclaimed refrigerants is something to consider. We were very fortunate with Emerald last year to be recognized by two industry organizations. So Environment Plus Energy Leader awarded us as a top product for sustainability last year. The ability to capture and reuse and reclaim and the avoidance of greenhouse gas emissions with Emerald refrigerants was recognized by Environment and Energy. And then Building Green, a really well-recognized environmental publication that's been around for many, many years, also awarded both our on-site services as well as our Emerald refrigerants, recognizing that, again, the lowering of the contaminants in a system, the utilizing of our services, the bringing back your HVAC systems to original design, lowering the carbon footprint, in conjunction with using Emerald reclaimed refrigerants, really has a significant impact on ESG, on carbon footprint. So we've talked a little bit about this. Again, Emerald and our side services, this is measurable activity that you can use for contribution to your ESG. We know the GWP of the refrigerant that was recovered and reclaimed. We know the pounds. You're able to utilize that you have certified paperwork from Hudson. When you're buying Emerald refrigerant, we have certified paperwork to say you're buying certified Emerald reclaimed refrigerant. Every pound of refrigerant that we buy is economic value to you in order to either fund a conversion or fund new equipment. The 3 R's of reclamation, I'll touch on them briefly, so we've got a couple of minutes for questions here. Recovered refrigerant that has been recovered out of a system, the only person that can reuse that is the system owner. Recycled refrigerant it's probably been run through a filter dryer as it's being recovered. It does not meet HRI 700, and again, the only person who can use that is the original owner of that refrigerant and that equipment. And then reclaimed refrigerant, which again is what Hudson would be providing. It's been fully returned to AHRI 700. It's been certified to AHRI 700 specs. If you put a pound of reclaimed refrigerant next to a pound of virgin refrigerant, you can't tell the difference because it has to meet or exceed that. And then at that point, anybody can use that. What distinguishes those 2 pounds of refrigerant is the environmental properties. The reclaimed refrigerant has a GWP of near zero because it's been reclaimed and recovered. Our process is very simple. Hudson would pick up refrigerant from your location. We're going to swap back cylinders like for like. You'll get a full report of every cylinder, serial number, refrigerant, weight, purity. Get a very full detailed report. Carbon footprint we can provide as well. And we're going to pay you for that recovered refrigerant. So you get the ESG benefit, you get the carbon reduction benefit, and you get cash to help fund your conversion. So I'm going to move to our next slide. We've talked a lot here, and I know that we've had a lot of questions coming in. We had a couple of technical hiccups there. So here's our details, and I'm going to open the floor. So for anybody who wants to get in contact, love to have a conversation. I'm going to open the floor back up to questions.
Awesome. Great, thank you. It looks like they have stopped, so we'll move forward. Sorry about that. Never seen that happen before. So you got a lot of questions in, so I will jump into them. How do you see the HFO landscape shaping out in the U.S. over the next few years in response to the F-gas regulations in Europe?
Yeah, so the EPA here is looking at F-gas slightly different than the regulations in Europe. It's so that those two things, that the timeline is slightly different. The industry here is moving towards HFOs. So again, but the transition will take some time because of the installed base. So over the next few years, you'll start to see an increase in the use of HFOs here in equipment. Again, a number of those HFOs require new equipment versus being able to retrofit. But Europe is slightly ahead of us in terms of the use of HFOs because of when they implemented the equivalent of the AIM Act. I hope that helps.
Yeah, it was great. So there was a question about what states you provide reclaim service in.
Yeah, that's a great question. So we are nationwide for reclamation. Because we arrange the pickup, the return of the refrigerant and the recovery cylinders We can actually pick up from the entire lower 48. We've brought refrigerant in from Hawaii and Alaska as well. And we probably go to tens of thousands of locations every year to get recovered refrigerant. So we're nationwide. And again, encourage you to reach out and learn a little bit more if we can help you.
Awesome. And kind of sticking in the reclamation area, how do household applications get refrigerants reclaimed? Does Hudson work with the contractors on household reclaiming?
Yeah, so we generally work with appliance consolidators where you might be turning an appliance in, and we will make sure that that refrigerant is recovered from the appliances before the appliance is scrapped. Again, it's an EPA requirement, so we work in that space as well.
Excellent. There's a question about kind of the different industries. So this person works in the building sector, but they have a family member in the automobile industry, and she's wondering if there's are the auto and building sectors held to the same requirements, or are there different requirements for those?
Yes, that's a great question. So mobile AC or automobile, but mobile AC covers more than just cars or passenger cars, have slightly different regulations in terms of recovery and requirements. However, the AIM Act applies across both industries. So the phasing down of the HFCs is as applicable in mobile AC as it is in buildings, but the certification requirements for technicians that work on that and the recovery requirements are slightly different.
Okay, excellent. Just have a couple questions here. So in California, less than 10% of residential HVAC changeouts are permitted. Interesting. Are these statistics about how much of that refrigerant is reclaimed, if any? Is it worth selling back for the changeout companies?
So the answer is absolutely. It is absolutely always worth selling the refrigerant when you're changing out our system. So refrigerant has significant value. And we're paying a lot of money for a lot of refrigerant. So I would just, aside from the environmental benefits, aside from the fact that it's required by law and the EPA, the economics of recovered refrigerant are significant. The AIM Act has led to them used recovered refrigerants being worth much more than they were even 2 years ago. And I would encourage everyone to think about it that way. Hudson will pick up refrigerant. We pay for the freight, we swap cylinders, and we pay you for the refrigerant. There is no fees on our program, so you can't lose money, and you're doing the right thing.
Awesome. I think we probably have time for one more question here, and it's, do you deal with refrigerant destruction as well? So safe disposal of CFCs, and if so, what is that process like?
So also a great question. We absolutely do handle disposal and destruction of all refrigerants. Generally, we try to put them into reuse, but we do work with some customers who specifically want their refrigerant destroyed, and we can facilitate that. So again, a whole paperwork train. We can give you all the documentation and all of the details that we have destroyed that refrigerant and permanently ensured it will never be released to the atmosphere. So again, I encourage you, whoever is looking for information on that, please reach out to me, and we will absolutely be able to help. And I would say we've got a lot of questions that we won't get to, Katie, so we'll try to answer them, offline and get back to everybody who wants to have a conversation.
Perfect. Yeah, they're still rolling in here too, so definitely appreciate that. So Kate's contact information is there as well as their site. So please reach out to them. Again, a recording of this will be made available to you all within 24 hours. And let me just make sure I hit all of the things. So please take a moment to provide feedback on this session for us as well. Hudson appreciates it, and so does Greenbuild. And so on behalf of Hudson Technologies and Kate and Greenbuild, I want to thank you all for joining us today, and we hope to see you at our next Greenbuild webinar. So thank you very much. Thanks, Kate. That was a lot of talking. So thank you.
Take care, everyone.